Alright, so we've talked a lot about least squares regression lines, linear regressions, looking at slope, looking at the y-intercepts, learning how to interpret all these things and understand all of them. And really, we can only use all this stuff if we have linear data, okay? And so how do we check that our data really is linear? And we've talked about r and r squared and how those are only appropriate if we do have linear data. So how do we know if we have linear data? And so that's what we're going to talk about. We are going to use the residual plots to figure out if we really have linear data. So the main purpose of a residual plot is to determine if the data is linear. And if it is linear, we are trying to figure out if this least squares regression line is appropriate to use and to help us to make our predictions. So there's a couple different ways that we can talk or make these residual plots. The first one is we can use our explanatory variables, versus our residuals. So what I'm saying here is we're going to make a scatter plot. Oops. We're going to make a scatter plot, and on our x-axis down here, it's going to be all over the place, right? Our x variable can be explanatory. Okay, and our y's are always going to be those residuals. Alright, but besides that, we have options. So we can use explanatory variables, we can use our response variables, and we can also use our predictions. So we could use all those y-hats. This would be y's and y-hats. Okay, and so we can use all of these different things to be on our x-axis if we really wanted to, where our residuals are always going to be on the y-axis when we make residual plots. Okay, so let's talk a little bit about this. So if we have a curved residual plot, so these are different things that could pop up. So if we have a curved residual plot, if we plot these and it's curved, then we have curved data, and so this is not appropriate. Our least squares regression line, remember it's for linear stuff, is not appropriate. Now, if we have this is what we want. So if we look at our residual plot and we see random scatter, a random scattered residual plot, I'll put scatter underneath there so you understand. Random scattered residual plot, then we actually have linear data, and so this is an appropriate prediction. So let's look at this. If we were to look at, you always want to look at your residual plot, looking at this, because sometimes it's really hard. Maybe we don't have the right scaling on any of our graphs, and you're going to see that because we're going to plot stuff on here on our calculator. It's going to be really hard to adjust the windows sometimes. So you always want to just make the residual plot and it'll pop up. So let's say this is our residual plot. We see that this is curved. Clearly see kind of a curve in here. So this is curved. Start looking always at your residual plot and work backwards. If this is curved, then this is curved. And even though it looks linear, if we were to change our windows and change our perspective, this would actually be curved. Again, we always want to start looking at our residual plot. Here, this is random scattered. This is random. I have stuff above, up below, it's all over the place. That means that this is actually linear. So first look at your residual plots, then look at your data. Alright.